Hello. So in this video, we are going to learn about a very important topic, linear and nonlinear differential equation. So let's get right into the business. So when we say linear, we meant linear in y prime, y double prime, y triple prime, etc. So it's the linear for the unknown function. So this basically means that there should not be any mixing of y prime, and y double prime, etc. So this simply means that you should not have any y square or y cube or y times y prime, or maybe y prime times y double prime times y triple prime, or y double prime cube. So none of them is allowed. Okay, so none of them is allowed. Okay, you can only have one term. You can combine all the term that has y. You can combine all the term that has y prime, etc., etc. And I'll look into the example. And it also means that the y and y prime and y double prime cannot be in the argument of other function. So for example, I should not have sine of y. If you do have sine of y, then it is not linear. I should not have ln of y prime, right? Or a tan of y double prime. Okay, so I cannot have y prime, y double prime, or y triple prime as an argument of other function. So that is also not allowed. So at the end of the day, all this means that for the first order, for example, the first order linear, right? So the first order, that means you only have the first derivative and less, right? Remember the order, we went over that in the last video. So for the first order, you can combine all the term that has y prime together. So you are going to have y prime, and you have some function of x times y prime plus some function of x times y equal to some function of x. Now all the x, you can bring it on the other side, or you can leave it on the right hand side. You can also bring this cx on the left and write equal to 0. So that's also okay. So that's like a standard format. That's an example of that is how you can write it down, a first order linear. Very similarly, second order linear will be, after you combine all the like term, if necessary, is going to be some function of x, I call it a of x, y double prime, plus some function of x times y prime plus some function of x times y equal to some function of x. Again, the term that does not have any y or y prime, I move it to the other side. So you probably get the pattern. By the way, the independent variable x, that can be anything. That can have sine x, x squared, x cubed. That we do not care. We're only interested in the unknown function, y prime, y double prime, etc. Just to make sure, let's write it down. Third order linear differential equation. Let's write that down. This is going to be some function of x times the y triple prime plus some function of x times y double prime plus some function of x times y prime plus some function of x times y equal to some function of x. So I write those function of x as a, b, c, d, e, whatever that function may be. So that's a general format for a third order linear differential equation. And any differential equation that cannot be written in this format is not linear. So why we are dividing differential equation into linear and nonlinear? Because in general, linear differential equation, we have some hope of solving. It's not easy. It will get very difficult, and many linear differential equation we cannot solve. But all the linear differential equation we are going to encounter in this class, we're going to learn how to solve it. So it's basically, once you go second order and higher, you're only going to concentrate on the linear differential equation. And another point is that typically when you have a nonlinear differential equation, you might be able to approximate that nonlinear differential equation with a linear differential equation. And then you solve the linear differential equation, and that will give you some approximate solution of the nonlinear. So that's another application of knowing the linear differential equation. So let's just go over some example here, right? So from 1 to 6, the question is it linear or nonlinear? So you can pause the video and answer number 1 to 6. I hope you pause the video. So I'm going to give you the answer here. So look at here, the number 1, that's linear. They are using t instead of x. So you can see that I have some function of t times y double prime plus some function of t times y prime plus some function of t, in this case a constant, times y equal to some function of t. So that's linear, right? Let's look at number 2. Because you see y square right away, that's not allowed. So that's non-linear. Number 3 is linear. Just like example 1, you have some function of t times y fourth derivative. In this case, actually, that's the function 1 there, right? All of this function is 1 here, coefficient. And you can see it satisfies the definition of the linear. So you have if some function of t times y fourth derivative plus some function of t times the third derivative plus some function of t times the second derivative, and so on and so forth. Let's look at number 4. Y square again is not allowed, so that's non-linear. Let's look at 5. If you look at here, y is inside the sine function, and that's not allowed. Y prime, y double prime, etc. cannot be inside of another function, right? That's the part of the definition. So this means this is nonlinear. Let's look at number 6. It is indeed linear. So you have the third order derivative, and then the function here is 1, right? Plus t times the first derivative plus cosine squared t times y equal to t cube. Okay, so it satisfies the definition of the linear. So this is linear. Remember, t is the independent variable. T is like x. So t cube, cosine squared t, we do not care about t. We only care about y, y prime, and y double prime, etc. By the way, in this differential equation, the y double prime is missing. In other words, the coefficient is 0 there. That's okay. You don't have to have all of the derivative appear. Thank you. I hope it helped you. And always remember, you can do it. Bye bye.